Hello friends, my name is AJ and welcome to the fourth practice FRQ for the 2020 AP Computer Science A exam. Today we're going to be going over question number 1 from the 2018 released FRQ, and this is the frog simulation question. This particular question again comes from an official release test, or the official released FRQ rather, from a previous year, 2018's administration of the AP exam. The link for the release test will be in the description below, so definitely recommend trying out question number 1 before we go over it. Alright, without further ado, let's get started. So we're going to go to question number 1 over here. And it says, this question involves reasoning about a simulation of a frog hopping in a straight line. The frog attempts to hop to a goal within a specified number of hops. The simulation is encapsulated in the following frog simulation class. You will write 2 methods in this class. So you can see that it's just a 1 class question, so we don't have to worry about 2 classes. And then let's look at some of the things. So we have our first field, which has goal distances. So distance in inches from the starting position to the goal. And then max hops, which is maximum number of hops allowed to reach the goal. And then we have the constructor, which it actually shows us how it is created. So we have distance and we have hops as our parameters. And dist is stored in goal distance and num hops is stored in max hops. And then we have 3 methods. The first method is a private method, which returns the integer representing the distance to be moved when a frog hops. So this means like how much does it move every time it hops, pretty much. Then we have 2 other methods, and these are the ones that we will have to implement as we solve the problem. The first one is the simulate method. And you can see in the comment it says simulates a frog attempting to reach the goal as described in part A. So it's going to return true if it successfully reached the goal during the simulation, and false if it did not reach the goal. And this will return, again, a Boolean. Then we have part B, which will run the simulation and return the proportion of simulations in which it successfully reached the goal, and that will be part B. Alright, so let's go to part A, where we are going to be implementing the simulate method. So it says, write the simulate method in which which simulates the frog attempting to hop in a straight line to a goal from the frog starting position of 0 within a maximum number of hops. The method returns true if the frog has successfully reached the goal within the maximum number of hops. Otherwise, the method returns false. So basically, you're going to be doing hops until the maximum number of hops has been reached, and the distance that the frog travels per hop again was specified using the hop distance method. So every time you're going to be hopping the amount that is returned by hop distance, and you're going to keep hopping until we reach the maximum number of hops that we can do. Alright, so it says, the frog simulation class provides a method called hops distance, which returns an integer representing the difference to be moved when the frog hops. And this can be both positive or negative. A positive distance represents a move toward the goal. A negative distance represents a move away from the goal. The return distance may vary from call to call, which basically means that every time you call hop distance, you may not get the same value in return. Each time the frog hops, its position is adjusted by the value returned by the call. So basically, its position will change depending on the distance of the hop. And so now we have 3 conditions. The frog hops until one of the following conditions becomes true. A, the frog has reached or passed the goal. The frog has reached a negative position, or the frog has taken the maximum number of steps without reaching the goal. And now we can look at this and see what they return. So you can see that when it does pass the goal, it will return true, for example, when it passes the goal, here, for the top 3. But then, if it ever reaches a negative position any time while you're looping, then it's going to return false. And at the same time, once you have exhausted all of your hops, if the final position is not equal to or greater than the goal, then it is going to also return false. So we now have a few of different conditions that we can use when we are trying to figure out what the simulate method will return. And that is it. Now it just says complete the simulate method below. So the first thing I'm going to do, and again, this is in JGrasp. I've been using JGrasp simply because it's easy to type in, and you can all see what I'm typing, and it's slightly faster and easier than writing it out. I'm going to add my curly braces to my simulate method, and I'm going to add the comment method so that we know that this curly brace is actually tied to the method. This again is not necessary. I've done this in the past videos. It's just good. It's just good practice so you know kind of how things match up. Okay, so the first thing that we need to do is, because we're trying to hop, right, and we're trying to move locations, we need to set some sort of variable that keeps track of the position of our frog. And so what I'm going to do is I'm going to type an int, right? And then what I can do is I can create a name for this variable. So like I can say a frog position, right? And I can set this equal to, if you remember up here, it said that the frog starting position is 0. Therefore, I should initialize this position at the beginning to 0. Okay? Now what I want to do is I want to hop, right? I want to keep increasing my position or decreasing my position depending on the hop distance. But this is a repeated process, right? We're going to be continuously hopping for the same number of times that the max hop field for my method right here, max hops, actually is. So I'm going to be continuously repeating for the number of max hops. There are a few keywords that were in there. One was repeating and one was for. So we're going to actually be able to create a for loop for this. And what we can do is I can say in I equals 0, which sets the starting counter variable. And then the condition for my loop is that the loop will repeat when I is less than my max hops field, right? This dot max hops. And then what I can do is I can add my count or my increment. So I is just going to increase by 1. All this for loop does is it simply repeats basically it repeats the same number of times as the variable max hops. So like if max hops was 5, the loop would repeat 5 times. If it was 8, it would repeat 8 times, etc. Okay, so now what we want to do is we want to somehow change our frog's position. And we're going to change it by whatever returns from the hop distance method. So I can say frog position plus equals, and then hop distance, just like this. Now you may be wondering why I am using the plus equals, right? You may be saying, well, what if it's negative? Well, even if it's negative, right? If I'm adding a negative number, right? Let's say I do 5 plus a negative 2, it's still going to cancel out and it's going to be subtraction. So even when you add a negative number, it will still count as subtraction. That's why this plus equals will work. Even if for example, my hop distance is negative 2, it would do 0 plus negative 2, which would be really 0 minus 2, which would be negative 2. So even though plus equals is here, it's not going to affect whenever hop distance returns a negative value. Okay, so now I actually have a few conditions that I need to check, right? So it says down here that the frog hops until one of the following conditions becomes true. First, the frog has reached or passed the goal. Once it reaches the goal, then it's simply going to stop repeating and it's going to return true. So, well, what do I know what my goal is? I know my goal because it is specified in my goal distance field for my frog simulation class. So I can do a simple if statement. I can say if my frog position is greater than or equal to my goal distance, so this dot goal distance, if this is true, then I can simply return true, just like that. Because again, the entire purpose of the simulate method is to basically return true once if the frog has actually reached the goal. So if the position is greater than or equal to the goal distance, that means it has reached the goal or surpassed the goal, and it will return true, and it will stop repeating. Now, one thing I did say, just for consistency, I do have these comments here, simply so that you know that, okay, this, for example, this closing curly brace is for the if statement, this is for the for loop. Again, it may increase readability. Okay, so now we have checked the first condition. Now we can check our second position, my second condition, rather. And the second condition is that the frog has reached a negative position. So if it reaches a negative position, it's going to return false. So if I know this, what I can do is I can say if, and remember, this is going to be while repeating, because it says here that it's going to, the frog hops until one of the following conditions become true. So it can hop until, for example, it reaches a negative position. And if it does reach a negative position, then the function or the method is going to return false. So inside of this if statement, I can say if frog position is less than 0, then I'm going to return false right here. Okay. Now the last condition that I have says the frog has taken the maximum number of hops without reaching the goal. In order for me to check this particular condition, right? That means that the maximum number of hops had to have occurred. And in order for the maximum number of hops to have occurred, it has to be outside of my for loop, because anything that I put inside of my for loop is going to be running as it's hopping, not when it's done. And it says that if it has taken the maximum number of hops without reaching the goal. Now, inside of my for loop, I was checking after I added the new position or the hop distance to my frog position. Here, I check if I actually reached or exceeded the goal, and I return true. Therefore, once this for loop is done running, right, and after this condition is checked, this particular line where I change my frog position is never going to occur again, which basically means that outside of my for loop, I don't need to check again whether or not the actual position is less than the goal distance, because it could have only made it outside of this for loop if it never exceeded the goal distance. Therefore, the only line that I have to do outside of my for loop is simply return false. Because the only way that it could have reached this line and it could have completed the for loop is that the frog hopped the maximum number of times, and it already checked that the frog position is still less than the actual goal value. So that's why here I don't need to check it again, and I add return false outside of my for loop. And another thing that I want you to be careful with is that if I were to add another if statement here, let's say I did it redundantly, then what's going to actually happen is I want to make sure that I have a return statement that's always going to run. So I don't want it to be inside of any condition, because if it's in some sort of condition, then it may not return, and this method has to return. So therefore, this having the return false separate outside of an if statement, because we already know that the condition should be false if the code runs past the for loop, that is why that it is outside of that if statement here, and it just says return false. All right, so that is part A. This is actually not that bad of a problem. All you have to do is you just have to know first about this return false down here, and then also you just have to know the correct location for each of the flags. So this particular problem, again, is just using loops and using simple conditionals. There wasn't actually even that much math and no strings either. So this would be a Unit 1, Unit 3, and Unit 4 type of problem. All right, so now we're going to move to Part B. So it says in Part B, write the runSimulations method, which performs a given number of simulations and returns the proportion of simulations in which the frog successfully reached or passed the goal. And then it provides an example. It says, for example, if the parameter passed to run simulations is 400, so if my parameter here was listed as 400, then and 100 of the 400 simulate method calls return true, then run simulations should return 0.25. It's simply a division, double division, and a proportion. So it says complete the method run simulations below. Assume that simulate works as specified regardless of what you wrote in part A. This is good because, let's say you make a mistake in part A, it won't necessarily hurt you in part B, as long as you know obviously what simulate actually does. And then it says you must use simulate appropriately to receive full credit. Okay, so I'm going to add my curly braces and do my comment for method again, right here, for again consistency. And now what I want to do is I want to create another counter variable, because what I essentially want to do here is I want to run a simulate, or I want to run the simulate method the same number of times as my actual input parameter, right? So, and I'm supposed to be counting the number of times that it returns true so that I can create a proportion. So I can say int, let's just say int true simulations or something like that equals 0, right? Because again, the starting value should be 0. Now I want to repeat the simulate method, right, for the number inside of my parameter. So I can create another for loop very similar to the one up here. I can say for int I, so I can initialize my counter variable to 0. I can set my condition for my for loop to be that I is less than num, which is my input parameter here. And then I can say I++, which means that it's simply going to, every time, the counter variable will increase by 1. So I can do open and close braces, and I can add my for comment. Okay, so now what I need to do is I need to check whether or not when I run simulate, it actually returns true. So I can create a Boolean variable, right? Because what my actual simulate method will return is a Boolean, right? And it's going to be either a success or not. So I'm going to say Boolean sim equals simulate, just like that. And that, all this does is it's simply going to store the result of my simulation into this Boolean variable called sim. Then I can say if the sim, or the result of my simulation, and in fact, I'm going to name this sim result just so that, it increases, again, readability and may help you understand rather than just a very short name. If sim result equals true, then I want to increment my true simulations counter. I could say true simulations plus equals 1, or I can just do plus, just like this. And by doing this, it's simply going to increase my counter variable every time there is a true simulation. Okay, and now the last thing I need to do is I need to return the actual proportion. Now, when I actually return my proportion, right, I want it to be a double type, because you can see here my return type is double. And because proportions are generally decimal, right? If I were to do integer division and return that value, it's simply going to either return 1 or 0. 1 meaning that 100% of the simulations were true, or 0, pretty much anything else, simply because the decimals are truncated. So like, let's say this example, if 100 of 400 runs were true, then it would be 0.25. But because if I were to return 0.25 as an integer, right, it truncates the values and it will simply be 0. Instead, it'll just cut off all of the valuable decimals. So when we're actually returning, we want to make sure that we are returning a double value instead of integer values. And so that's the only thing here, if you notice, that both my input variable is an integer as well as my counter variable is an integer. So if I were to divide, for example, true simulations divided by num, the resulting type is going to be an integer because it's integer division. In order for me to make this a double division so that I actually get decimals, I need to cast one of these values to a double type. So to do this, I can just add my return statement, and I can do true simulations divided by num, right? So this would be the integer division. Now I need to cast one of these values, and to cast it, I can simply add open parenthesis, double, close parentheses, just like that. And by doing this, I'm simply casting my true simulations integer variable into a double type. And then once I do a double divided by an integer, my return value will be a double. All right, everyone, that is the solution for the frog simulation question, which is 2018 number 1. This question, again, falls into that methods and control structure category of questions instead of array list. Again, if you don't already remember, there are going to be two different types of questions on the exam, or two questions. One of them is going to be an integer either an array or array list, which is units 6 and 7, or it's going to be methods and control structures, which is units 1 through 4. And this is definitely more of a 1 through 4. You're pretty much covering everything, right? You're covering loops, you're covering conditionals with if statements, you are covering even math right here, and casting variables, as well as running methods. Alright, everyone, thanks for watching. If you liked the video, feel free to like and subscribe for more content, and more review videos for the AP exam will be coming in the future.